So one of the things that is a common place to observe is that data are available everywhere in our lives these days. They're easy to get a hold of, they're easy to acquire, and people and organizations are generating masses and masses and masses of data. And one of the things that can be hard about all this data is essentially that there's a comparative lack of attention for each individual data item, because the amount of attention that we have has not increased over time, whereas the amount of data that we have access to has increased massively. So here's a couple of examples. This is about student loan debt over here on the left, and on the right you see a thing about Vancouver housing prices, about how they've changed over time. So one of the things that is a good thing to observe is it's usually a lot easier to understand the data that we're talking about when we can see it. It's typically a lot easier to understand a trend or understand how things are different from one location to another in this case, when you can see the actual difference presented in a plot that is organized in a manner that's easy to understand. So this one is about the proportion of international students by program level in the populations of the individual countries shown here, with Australia, UK, New Zealand, Canada, the OECD average, Ireland, and the United States. So as you can see, there's a big difference between bachelor's, master's, and doctorate level attendance in these countries. So what is visualization? Visualization is a computer-based system for the purposes of creating visual representations of data designed to help people carry out tasks more effectively. It's kind of a general definition of what we're on about, but the purpose here is to use computer systems that generate pictures for the purposes of helping users using those computers to analyze the data that they see. And this is done in a variety of domains. So this thing that you see down here, this circular plot, this is something that you would see done in genomics. Up here on the upper right, this is geographers would use this for understanding landscape and so on and so forth. This is a brain region diagram generated for neuroscientists. This is a financial spreadsheet and analytical system, and this is a visualization called a graph, node link diagram for the purposes of network analysis. And the location of data is not just in visualization systems. You also see this in the public media. So this is an example of the kinds of charts that Maclean's magazine thinks that all Canadians should watch, and they've been doing this for the last 4 years now. So this one's talking about vulnerability of housing prices. This is about increasing or decreasing our performance. And typically the stuff you see in magazines is about economics and other things of that nature. So the thing that's new about visualization is the massive quantity of data. And IBM has suggested that there's 4 V's: volume, that is to say the total quantity of data; velocity, the number of new data that are arriving every day; the variety of information; and the fact that some of that data is not of ideal quality in the sense of you knowing for a fact that things are true. And so what big data and visualization and visual analytics is about is to try to derive value from the massive quantities of visual data that's arriving. Why do we care? Well, this word kind of indicates the vast set of concerns inside the domain of big data or data analytics. And one of the big things that's very important, as I mentioned already, is the explosion of users and questions, which goes along with the explosion of data availability and the ubiquity of computing systems. Professional, social, and personal spheres are all sort of perspectives that people take on analyzing and understanding data. And what has happened in society is that the literacy and access to data has significantly increased and improved over the last 20 years. Another thing is that organizations are expecting data skills of their employees to be improved over past years, and data skills are in demand in the workplace to grow more than 80% by 2022. And data is the substrate of collaborative decision-making and implementation. And so it's very important for people to be skilled and knowledgeable about how to interact with data and how to do interesting things with the questions that they're presented. So big data is about anything that we cannot manage with the current reasoning support that we have. One of the hopes is that automated techniques or mechanical techniques can analyze a certain amount of data, but I think throughout the course we'll illustrate why there is a useful balance of interactive techniques that we'll talk about in our course, analytic techniques, and automated techniques that have already been verified to be suitable on the data collection that you may have. So we're going to talk about the person-in-the-loop techniques throughout this course. So discovery and interpretation and communication of meaningful patterns in data is what this course is about. So this thing here is a parallel coordinates plot of a number of automobiles, and it's the dimensions here are the number of cylinders in the engine, the displacement or the size of the motor, the weight of the car, the horsepower, acceleration, mileage, and the year when the car was manufactured. And this thing indicates a relationship amongst all of the data, all of the cars that were manufactured between 1970 and 1983 in this thing. And you can interact with this plot in order to get a good understanding of what's going on. What you're typically wanting to do with this is to analyze this data to understand about what is going on in the underlying phenomena. And analytics are everywhere. So this is a analytics built by Vancouver Coastal Health and Fraser Health that is analyzing, interestingly enough, binge drinking one or more times per month and the prevalence of that throughout southwestern BC. And surprisingly, there seems to be quite a significant amount of binge drinking in the Whistler area. I'm not 100% sure why that might be. But in any case, this is some data that helps measure that and enables an analyst to look at the geographic distribution of this particular activity that the health districts would care about. This one here is another type of analytics. This is significantly more personal. This is about an individual person's finances, and here we can see once again some visual analytics techniques are being brought to bear, although they're very simple ones at the bottom of this display. You know, as I said, data are everywhere, and there can be about any sort of topic that you might be interested in. And this one is a standard thing for Vancouver residents or Lower Mainland residents to care about, and that is the change of housing prices over time. If you want to acquire a house, you might be a bit concerned. And this thing here, this headline here, is saying something that in some sense the data is telling not quite the same story when you see a plot of Vancouver housing prices. The headline says, Vancouver average detached home prices see worst slide in 39 years. It sounds like it's a big old disaster, but what really has happened is that there was a big run-up in 2015-16, and then a significant decrease of pretty much the same size, so that housing prices were back to the previous state from 2 years before. So that's what the headline is paying attention to, but the real story is a little bit more nuanced than that, what the headline says. Here is another way of viewing that, and that is smoothing that information much more significantly and making the situation seem significantly less dire than it actually is presented in the headline. So what we're interested in doing is taking data that you see over here in the bottom left and using at first visualization tools to transform that into information that we can use to understand relationships among the data in the data set, and as we bring more context to bear to the problem we're interested in doing visual analytics, so that we can gain some knowledge and understand the patterns among the relationships that are present in the data. Okay. What visualization is intending to do for us is to turn data into information. So here's an example of the European continent and the increases and decreases in population throughout Eastern and Central and Western Europe. And as you can see, they're using color here to indicate where a population is increasing and using the blue to indicate where populations are decreasing. And the suggestion made in this map and in the article in the Independent in 2015 is that it's possibly the case that, say, parts of Germany which at the time were experiencing decreases in population, as you can see, the blue area in the former East Germany, maybe they could find room for asylum seekers coming from the Middle East and from Syria. One of the things that visualization is good for is helping us derive new questions about the data that we may have, to, among other things, enable us to do formative rather than summative analysis. Formative analysis is the kind of thing that you do when you're trying to understand the aspects and nuances of the data set that you've got. Summative analysis is the kind of thing where you're trying to confirm or perhaps deny a hypothesis you might have about data. So in this case, we see that there is this plot which plots the occurrence of acute diarrheal diseases on the horizontal axis and acute respiratory infection, the number of cases, on the vertical axis. And one of the things that's interesting is that there's a correlation between those two things, with a significant outlier right here, where there is, you know, a significant amount of respiratory infections present. This is all pre-COVID, by the way, and it would drive a person to investigate why is the case that, say, this country or this place has a significant amount of respiratory infections that are not correlated with diarrheal diseases. Another thing that visual analytics is intended to be good for is to drill down and analyze and recontextualize analytical processes. So here is a political analysis. This is about Herman Cain's 999 tax proposal. He had this idea that the U.S. Income tax should be reformulated so that it was a flat tax. That is to say, everybody pays the same percentage, and then some organizations analyze that according to the bottom, second, middle, fourth, and top 20% of the income distribution, and they discovered, you know, that everybody outside of the top income distribution would experience a tax increase, and the top 20% would experience a significant tax decrease. However, if you slice a little bit more finely, what you do notice is that the top 1% top 0.1% of earners in the United States would experience a tax decrease of $1.3 million. So it's a very significant impact that's that's hidden to some degree by this much more coarse analysis of what's going on in the tax plan that was suggested by Cain. So analysis, however, the reason why we need visual analytics and visual analysis is that analysis is often complicated by our own individual cognitive limitations. These are cognitive limitations that all of us have to some degree. And one of the major limits that we have is, I'm sure you remember this from other courses, is that our brains manage limited short-term memory by doing one of two things. One is to consolidate into long-term memory using rehearsal, or perhaps there's something salient in the information you're trying to remember that makes it easy to remember, or you forget it. And without some way of offloading information to offload information, thinking analysis become more difficult. And so what visual analytics does for us is to provide a place to offload our thinking about a collection of data. And this is called an external memory, and pictures are particularly good at managing information in that way. So here's an example of a very complex problem that became salient when an airliner hit a flock of Canada geese when taking off from LaGuardia Airport in New York City. The plane landed in the river. There was a movie made about it. And this is over on the left is a table of all, a table of all the bird strikes and deer strikes and animal strikes of all aircraft that is collected by the FAA. Every single time an aircraft hits something, it's recorded by the Federal Aviation Administration. On the right is a set of visual analyses done to gain an understanding of when and where and what kind of animals are struck. And it turns out that the most common and dangerous creature for aircraft is the Canada goose. The location for Canada geese is shown here on the right, on the map on the right. Most of those strikes take place in the eastern USA, but also there's a very strong correlation there with the total population density of those areas. So some of the factor that's present here in that map is the fact that lots of flights are landing and departing from airports in that region because there's a lot of people who live there. But this is a plot of deer strikes. Yes, indeed, it's possible to strike deer with aircraft, and I thought that would be kind of interesting. Okay, so now I have some questions for you. I'm going to leave this up for a while, and at the end of this video, which is coming up very, very, very soon, I have 3 questions about this table. And that is, number 1, which state has the highest income? And number 2, is there a relationship between income and education that you can see from the data? And number 3, is this consistent everywhere? So what I'm going to do is I would like you to pause the video at this point, and I will pause the video as I play it live, and I want you to stare at this data and get an understanding of what its distribution is, where are the extremes, the highest and lowest points of income, and what the relationship is between income and education. So I'm going to stop the recording here.